All right, STAT1800. The purpose of this video is to introduce you to something called Z-scores. Z-scores are just a measure of location that we use, and we are going to, in this PowerPoint, going to look at Z-scores for a sample. We'll move to Z-scores for a population, I think, in maybe lesson 3, but we'll get there soon enough. So a key concept in stats is to find the location. We will find that we use percentile rankings, Q1 and Q3, which we've talked about previously, are actually also measures of location. But what a z-score gives us, it gives us a couple of pieces of information. First of all, it tells us whether it's above or below the mean, and then it tells us how far away from the mean in standard deviations that the score falls. So again, a z-score is a measure of location. So the standard, z-score formula is just to take the x, so x just stands for the score from the distribution. X bar, of course, is the mean, and of course, S is the standard deviation. The really only mistake that I see students make at this level when they're calculating a z-score, because as you can tell, there's not a lot to it, is they fail to put the numerator, the x minus x bar, in parentheses, and they end up getting an order of operation mistake, and actually just a sloppy mistake to get the wrong z-score. So other than that, it's actually a pretty easy concept in terms of learning and executing. So rounding off rule, we typically round z-scores to 2 places. So if you had a z-score of like 2.317, 2 or whatever, so we would round the z-score to just 2.31. Now, if you're entering a z-score in my stat lab, enter the z-score however my stat lab instructs you to do so. So certain important properties of z-scores. Again, a z-score is a measure of location. It tells us how far above or below the mean that the value is in terms of standard deviations. It's a unstandardized measurement. It's a great way to identify an outlier, like a data value that's an outlier. So if we have a z-score that's greater than 3 or less than -3, we classify that value as an outlier. And the positive and the negative component, if we go back to the z-score formula, we can see if this number, the x, is bigger than the mean, then this part has to be positive. 8 minus 5 is a positive number. So if this number is bigger than the mean, this has to be a positive number. Standard deviation always has to be positive because we take the square root. So if I have a positive z-score, it tells me that the mean is, that the value we calculated the z-score for is above the mean. Now, if this value is below the mean, such as 2 minus 5, then this part becomes negative. Your z-score becomes negative, and a negative z-score tells us that the score is below the mean. All right, so let's do some calculations, dive into some examples. So if we wanted to compare, for example, ACTs and SATs, and let's say that we have an ACT of 26, which came from 106 students with a sample mean of 22.5 and a standard deviation of 5.5. Let's say we have 140 students and we have an SAT in there, 1,400, and the mean SAT is 1247, and the sample standard deviation is 188. Well, what we can do is we can calculate each one of the z-scores. So we can calculate the z-score for the ACT of 26 by taking x, replacing it with 26, x bar, replacing it with the mean, and s, replacing it with the standard deviation. So what I would urge you to do right now is pump the brakes, pause the video, and just make sure that you can put 26 minus 22.5 divided by 5.5 in your calculator, and you get 0.64. Now I'm going to do in my calculator, but I'm going to do it incorrectly. Now, if I don't put the numerator, the x minus x bar in parentheses, and I get something like 21.91, that's wrong because there's an order of operation issue. So anyway, assuming that we can put the numerator in parentheses, it's a pretty easy calculation. An SAT of 1400, again, take 1400 minus the mean, divided by the standard deviation, and we get 0.81. So the interpretation of these, we would say that an ACT score of 26 is 0.64 standard deviations above the mean, and we would say that an SAT score of 1400 is 0.81 standard deviations above the mean. We interpret as above the mean because the z-scores are positive. So we can, if we're really interested in comparing the SAT and the ACT score, because the SAT score is farther above the mean, then it is a more extreme score or a higher relative standing. So again, it just provides a measure of location. Neither score is an outlier. More about that in just a second. IQ scores are calculated on 32 randomly selected students. They have a mean of 103.5, standard deviation of 16.9. Calculate and interpret the z-score for a 165 IQ. Same thing, put 165 in for the IQ. The mean is 103.5. Divide out by 16.9. I get 3.64. So I would say that an ACT of 165 is 3.64 standard deviations above the mean. Now, I'll go into more depth on this in just a second, but anytime we have a z-score that's above 3 or below -3, then we classify that as an outlier. So since 3.64 is clearly above 3, we would say that an IQ of 165 is an outlier. Gestation periods, mean of 266 days, standard deviation of 16 days. Calculate and interpret the z-score for a gestation period of 225 days. So same thing, insert 225 for x, subtract the mean, divide by 16. Since the value we're calculating the mean, calculating the z-score for is below the mean, 225, less than 266, we end up with the z-score that's negative. So our interpretation there would be a gestation period of 225 is 2.56 standard deviations below the mean. Again, that below comes from the fact that our z-score is negative. So that's one of those things you just got to tattoo to the brain. Make sure you get it in written in your notes and kind of flashing neon lights, if you will. But again, using the criteria of -3, +3, a gestation period of 225 would not be an outlier because it's not below -3. So using z-scores to identify outliers, again, if we have a z-score less than -3, we determine that is a low outlier. If we have a z-score greater than 3, we call that a high outlier. Any z-score between -3 and +3, we say that they are not an outlier. Another way of talking about outliers is just saying they are significant values. That's more of a general term that we'll run into later. Your textbook for this class doesn't use significant at this level in this chapter. It uses high, it just uses whether or not the value is an outlier. All right, so there's a data set in your textbook, data set 24, I believe, on earthquakes. And there's an earthquake in there that has a magnitude of 4.01. And turns out that the mean is 2.572 with a standard deviation of 0.651. So by the standard that I just presented to you, is the earthquake that has magnitude 4.01 an outlier? Well, calculate the z-score. So I take 4.01 minus the mean divided by the standard deviation. I get 2.21, so that tells me that a magnitude earthquake of 4.01 is 2.21 standard deviations above the mean. This is not greater than 3, so the magnitude is not an outlier.